we haven't talked about metallic compounds in detail, so we're going to jump in right here. Metallic compounds, the metal atoms come together, form interaction, and they arrange themselves nicely and packed tightly in a rigid framework, just like an ionic compound. We call lattice. Okay. The only difference from the ionic compound is in metallic compounds, there's no anion. Of course, it's just ion. Right? I'll give an example such as the lithium lattice. So the valence electron of lithium, so valence electron of 1, is held loosely by the proton in the nucleus and allows it to be able to move semi-freely to make a sea of electrons. That's what we call it. Okay? An ability to move of this electron to move semi-freely allows lithium lattice to conduct electricity. Okay, so that's why metal can conduct electricity, because the valence electron can move semi-freely. All right, so delocalized electrons, so they can conduct electricity. All right, and when the valence electron is gone from the nucleus, right? So that's which means that lithium become a lithium ion. So we have lithium ion in here. Okay, it's all lithium ion. The valence electron already moved around. All right, and the interaction that hold this lattice together come from the proton in the nucleus and the electron, the inner electron, which now become a valence electron now, of the different atoms. So it looks like that. Nice. So the proton in here associate with the electron of this atom, and the proton in here from interaction with the electron of the next atom. All right. So aluminum, right? Maybe check. Oh, hold on. Let's get back to at the beginning. So aluminum lose 3 electrons, right? Become aluminum plus, and the interaction come together from the aluminum 3 plus in rigid framework called lattice. All right. So this is how metallic compounds come together from interaction. All right. Now, if you look at the melting point of a metallic compound, comparable to the melting point of an ionic compound, okay, because it's charge to charge interaction, right? So in ionic compound, the interaction is it comes from the cation and anion, they attracts. In metal, come from the metal ion, which is the cation, and the electron of the atom on the next to it. Okay. All right. Now, metal is malleable and ductile. Okay, and the reason is, look at right here. So if I have the interaction come from the interaction in the metallic compounds come from the proton in the nucleus and the electron of the next atom, next ion. Right? Let's say if I have a hammer and I hammer right there, right? The metal does not break. Okay, so metal does not break, so it moves a little. The interaction is still there. The interaction is still there. So instead of breaking, so we call it right here is bending. That's the reason why the metal is malleable and ductile. Malleable means you can be pound, can be forged into a different shape. Ductile means can be stretched into wire, look like that. It's a copper wire, all right? But this, you can't do this with the ionic compounds. I'll take a look what happened, right? In ionic compounds, the lattice is an alternate arrangement between anion and cation, like that. If I hit it, let's say if I use a hammer and hit the ionic compound, then you look at the framework. If you hit it positive, positive, negative, negative, they are next to each other. Like one more time, hold on, right there. Hit it, whoop, negative, negative, positive, positive, negative, negative. They are next to each other and then repel. That's the reason why if you hit an ionic compound with a hammer, with a force, they break. They are not malleable like in metallic compounds. Okay? All right, now concept test real quick. So describe each of the following as ionic, metallic, or covalent compound. Start with the calcium fluoride. Well, calcium fluoride, we have a cation and an anion. So this we call an ionic compound. Glucose, C6H12O2, there's no metal in here. So it's totally a covalent compound. All right, covalent compound. Now, next one, bronze, which is an alloy, not alloy. So ALLOY, alloy of copper and tin. So in bronze, look like this. These are just metal in here, right? It could be a multiple metal, right? It doesn't have to be one metal. So this is an example of metallic compound. And lastly, we have table salt, sodium chloride, cation, and anion. That's totally an ionic compound. Okay. All right. Let's moving on to a covalent compounds.